Hello, everybody. Today we will be solving problem 8 of the 2019 AIME II. The problem reads, the polynomial f of z is equal to a times z to the power of 2018 plus b times z to the power of 2017 plus c times z to the power of 2016, has real coefficients not exceeding 2019, and f of the quantity 1 plus square root of 3I over 2 is equal to 2015 plus 2019 square root of 3I. Find the remainder when f of 1 is divided by 1000. Okay, so first of all, f of 1 is just a times 1 to the 2018 plus b times 1 to the 2017 plus c times 1 to the 2016. This is just equal to a plus b plus c. We want this divided by 1000. We want the remainder. Okay, now we look at this. We look at this value 1 over 2 plus square root of 3 over 2I. We're given that f of this is 2015 plus 2019 square root of 3I. And what can we do? But we can realize that this is equal to cosine of pi over 3 plus I times the sine of pi over 3. So if we're going to call this value omega, we have omega is cosine of pi over 3 plus I sine of pi over 3. Then we have there's a theorem called the Moivre's theorem. It states that if we have a complex number, let's call it z, such that z is r cosine theta plus I sine theta, r times the quantity cosine theta plus I sine theta, we have z to the power of n is equal to r to the power of n, r to the power of n times cosine of n theta plus I times sine of n theta. Right, and in particular, we have omega to the power of 6 is equal to 1 to the power of 6 times cosine of, well, 6 times pi over 3 is 2 pi. Well, cosine of 2 pi plus I sine of 2 pi. We can realize that cosine of 2 pi is 1 and sine of 2 pi is 0, which means that this is equal to 1. So omega to the power of 6 is 1. And omega to the power of 2016 is omega to the 6 to the power of 336, which is going to be equal to 1 to the power of 336, which is just 1. So we realize that f of omega is really a times omega to the power of 2 plus b times omega times c, all times omega to the power of 2016. This should be a plus, sorry. Omega to the power of 2016. But since that's just 1, we can just multiply this by 1. So we get f of omega is a times omega squared plus b times omega plus c, right? And we have omega squared is cosine of 2 pi over 3 plus I sine of 2 pi over 3. This follows from de Moivre's theorem. This is going to be equal to, well, cosine of 2 pi over 3 is negative 1/2, and sine of 2 pi over 3 is square root of 3 over 2. So omega squared is negative 1/2 plus square root of 3 over 2I. So a omega squared plus b omega plus c is going to be a times negative 1 over 2 plus square root of 3 over 2I plus b times 1/2 plus square root of 3 over 2I plus c. And since A, B, and C, they have real coefficients as stated in the problem statement, we can group the terms like this is equal to -1/2 A plus 1/2 B plus C plus square root of 3/2A plus square root of 3/2B all times I, right? We have that this quantity is equal to 2015 plus 2019 square root of 3I. So what do we have? Since A, B, and C are all real, we have 1/2 A plus 1/2 B plus C is 2015, and square root of 3/2A plus square root of 3/2B equals 2019 square root of 3. And from this second equation, we have A plus B equals 2019 times 2. But we have that the real coefficients do not exceed 2019, right? And what does this mean? It means that since A plus B is 2019 times 2, we have that A equals B equals 2019. That's the only way we can have both of them not exceeding 2019, because if one of them was smaller than 2019, the other one would have to be bigger than 2019 to get the sum of 2 times 2019, right? So we have A equals B equals 2019. And from this equation, we can get -1/2 times 2019 plus 1/2 times 2019 plus C equals 2015. These two terms add to 0, and we're left with C equals 2015. Finally, A plus B plus C is 2019 plus 2019 plus 2015. This is equal to 6,053. So our answer is 53. Thanks for watching, and I will see you next time.